So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Thank you so much for the confirmation, everyone. So let me start by introducing myself for those who have joined for the first time. So my name is Neeraj Khedia, and I've been working in this IT industry for almost 10 years now. So now let's get started. The main agenda for today's session is we'll be discussing on what exactly is cloud platform, what are different service models available in cloud platform, why exactly we need cloud platforms, and what exactly is AWS as in Amazon Web Services, what are different domains available in AWS, what are different services available in AWS, how the pricing works for AWS, and how we can start with the data migration, how we can start with migrating our application to the AWS infrastructure, right? And then we'll be having a quick discussion on developing the entire architecture and how companies are using AWS to solve their cloud computing requirements. All right. Now, first of all, let's understand the basics of cloud computing. Why exactly we need cloud computing? Now, for example, let's suppose we want to host a static website, right? Then we can now, when we are host a static website or any kind of application, both for web or mobile based, if we want to do support or deploy any particular application or website, then traditionally we had to buy a stack of servers, which will be holding up the entire data and which will be working as a main computation environment in which this application will be up and running. Then we have now, once we buy those stack of servers, that means we have to invest a good amount of money in buying those stack of servers, right? And plus we have to invest in monitoring and maintenance of these servers on our own, right? That means here we have to take care of everything from buying the infrastructure to making sure that the entire infrastructure is updated in the current software department, and again making sure that these entire servers are up and running all the time. That means taking care of the entire deployment as well as making sure that the entire process is well monitored, and the maintenance is also done from our own end, right? When we deploy something traditionally. And now the main drawback of this one is that this entire setup is expensive, because again here we have to, now when we are purchasing a stack of servers, obviously we need infrastructure in order to store those physical servers as well, right? We need to make sure that we are investing a good amount of time and as well as money in making sure the entire system is up and running without facing any kind of issues, right? And depending upon the incoming traffic, suppose if we for some time we see the traffic getting increased and sometimes we see the traffic getting decreased as well, that means we need to have the entire application scaled up and scaled down, and traditionally we have to take care of these scaling up and scaling down manually, right? But again, these things are required when we deploy any particular application out there. And then after introduction of cloud computing, again, basically cloud computing is what? The entire infrastructure that is required to deploy the application remains as it is, right? Because again, it needs, any application needs to have a server, any application needs to have a database created, the entire servers also need to be maintained, and everything needs to be done, right? That means there hasn't been any kind of I can say any kind of technologies being overwritten here, but again the main setup of deployment has changed. That means instead of us taking care of everything, now everything is deployed on cloud. That means now today if we have to deploy a website, then we can, now instead of buying the servers on our own, instead of taking care of the server deployments on our own, we can, and again which will take almost a week in order to buy the servers, set up the entire operating system, set up the entire environment. Nowadays, if we want to launch a website, we can launch it within 15 minutes. We can launch it within 15 minutes if we want, right? That's how fast it has been, all thanks to cloud computing. Because here we already have the stack of servers already available, which we can simply hire, which we can subscribe to, and then we can simply get started on top of it, right? Whether we need a server, whether we need a storage service, whether we need any database services, or everything is now available to us as a solution, as a software itself, which we can subscribe, and again, that means we don't have to take care of any kind of manual implementation, maintenance, taking care of scalability. Everything is now taken care by the cloud computing platforms. And that's why these all services, like we have on cloud computing, we get the entire pile of, like the complete pile of services, including computation, database, storage, networking, everything, every kind of service that we need for the application deployments, right? And even for data analysis, for data science, for handling large volume of data, these all services are now available as a cloud service on these different platform providers here. All right. Now let's understand why exactly we need AWS here. Now AWS is basically the main cloud computing platform that is owned by Amazon. It is, again, it is one of the, we can say, the first most popular cloud computing platform that was ever deployed. So it started in 2006, and now it is having the biggest market share in the entire cloud computing providers. So AWS has the biggest market share, then followed by Microsoft Azure, and then followed by Google Cloud Platform, right? So that's the entire infrastructure of AWS here. So because AWS, as compared to other platforms, right? As compared to other platforms, AWS here offers 6 times better capacity. That means 6 times better performance as compared to all the platforms combined. All the platforms combined. And that's why AWS is the most popular cloud computing platform for every kind of team, for every team globally, right? And that's the market, and that's why this is the market share of AWS as compared to other players. Earlier it was even higher. Earlier it was more than 45%, but now it has been reduced to 31% because of multiple small players also coming up in the market here. But still, AWS still governs the highest amount of, or you can say highest amount of market share for different cloud computing platforms, and offering flexible pricing on top of it. All right. And now let's understand what exactly is AWS. So AWS is simply a cloud computing platform offered by Amazon, where AWS is a collection of more than 90 plus services. AWS is a collection of more than 90 plus services ranging from computation, databases, storage services, analytics, IoT, machine learning, data science, big data. So there are multiple data warehousing, there are multiple services available, right? And that we will be looking at step by step as we move further in AWS domain platform. Now let's explore the different domains available in AWS here. Now AWS, as we had discussed, AWS is a collection of more than 90 plus services, right? So here we have multiple services on computation, on storage, databases, migration, networking, management tools, security and identity, compliance, and messaging, right? So there are multiple services here that we can use, that we can get started with. So now let's explore these services one by one. So first of all, here we have a computation service. So now in computation service, now when we say computation, we simply, now in simple layman terms, we simply mean setting up a server, like setting up, like just like we set up a virtual machine, right? For running and for setting up any application. So here we simply mean by setting up a computation service as a server itself, as a virtual environment itself, right? Where we can simply start using it in order to set up and run any particular services or any particular application, whether web, mobile, or any kind of application that we want to run as a part of computation service, right? And in computation services, here we have 5 main services that is offered under AWS computation service. First of all, here we have EC2. Now EC2 is the abbreviation used for Elastic Cloud Compute. EC2 is simply an abbreviation used for Elastic Cloud Compute. And excuse me for this beautiful calligraphy here, guys, because again, that's what happens when we try to write using our mouse and the touchpad. So here EC2 is simply Elastic Compute Cloud here. So as part of EC2 service offered by AWS, right? So EC2 is a full-fledged, we can say, just like we deploy a VM here, just like we deploy a virtual machine, that's the same way here we have EC2 services, right? Now, next, now EC2 can be, EC2 can be easy to deploy it here. And again, we can get started on deployment of these different servers one by one. We can do that. All right. Now, before we jump on how to get started on seeing these services here, let's do one thing. Let's simply go ahead and create our account on AWS first, so that we can see how we can get started on creating the account on AWS first, and then we'll be coming back and resume discussion on these services, right? So now for creating the account on AWS, we simply can open the browser, and in the browser we can simply type in aws.amazon.com. So here's a link that we have to type in the browser in case we are using AWS for the first time. Let me share this link with everyone. Here you go. So here we can type in aws.amazon.com, and this is the page that we will be looking at, where we can see the review of all the services, a brief overview of all the services offered under AWS. So as we had discussed, now AWS offers multiple services, more than 90 plus services on analytics, on application integration, AR and VR, cost management, blockchain, for computation services, customer engagement, databases, developer tools, media services, Internet of Things, machine learning. So there are more than 90 plus services and different categories that we can choose, and then we can get started on, right? And to start, what we have to do is we simply can scroll up and click on this option which says sign in to the console. Let's click on it. In case we already have an account on AWS, we can simply go ahead and use it. So here we can enter our email addresses here. In case we already have the account here, we can enter the email address, or in order to start, we can simply click on this option which says create a new AWS account. We can click on this one. And now we can enter the email address, a password, confirm password, AWS account name. Just like we sign up for any other platform, we can enter all of these details one by one. All right. Now remember, when we are trying to sign up for AWS, we do need an active credit or debit card, because AWS platform needs that in order to authenticate our account details, right? So we need to have an active credit or debit card that we need to enter as a mode of payment. Now, not to worry, once we enter the card here, our card will be charged a nominal fee of 1 INR, that will be reversed as well once the transaction has been authorized, right? So it is done just to make sure that, just to cross check that the card is active, up and running, and then we can get started on having the access to the AWS account here. All right. So now once we have the sign up done, then we can come back. Now, since we already have the account here, let's log into our dummy account first. Let's go back and let's log into our dummy account. Let's enter the email, our password, our MFA as a multi-factor authentication. Once we sign up and once we authorize and verify our payment details, we will be taken to this particular home dashboard for AWS, where we can get started on using these services one by one. So as you can see here, we have all the complete list of all the available services for our account. And when we have created the account here, we can simply set up the MFA as well, that we will explore once we start our session on AWS. All right, so that's how we can sign up to entire AWS account here, as we can see here, right? Now, once we have the access, now these all are different services that we can use to get started, right? So first of all, as we were discussing on the computation services here, let's go back to our slides. So first of all, here we have EC2. So EC2 is simply a full-fledged server, like a VM, like a virtual machine that we can deploy and get started on our applications, right? Then here we have Lambda Service. So Lambda Service is basically a serverless computing platform that we use in order to simply check, or we can say run any kind of testing of any kind of applications as well as a part of Lambda, right? So in simple layman terms here, now in order to execute any particular application, we need to deploy, we need to create an entire instance for it as well, right? That means here we do need to create an entire instance for it, then only we can get started. Or suppose if we are developing the entire application and we have only one module to check if it is working fine or not, right? Now, instead of deploying a full-fledged server using EC2, right? What we can do, we can simply use the Lambda service. We can simply use the Lambda service offered by AWS so that this entire code can be uploaded to the Lambda service offered by AWS, and this entire computation will run only for executing this particular component that we need to test here, right? Suppose that application has been executed for 10 seconds, right? That means here the entire server, the entire computation platform will be up and running only for 10 seconds. And that means here we will charge only for these 10 seconds, not more than that, right? As long as the entire code is up and running here. And that's exactly what we mean by computation service offered by AWS here. Now, next is we have Elastic Beanstalk. So Beanstalk is the hardware. That means hardware and the entire environment, right? For example, let's say when we are trying to deploy a PHP application, right? Now, as you know, if the application is built on PHP, so can we simply upload the file on any server and this PHP will start working? No, it won't, because PHP websites, PHP based code, it needs a PHP server. It needs a PHP server up and running. Then only the entire coding for PHP can be compiled and executed, right? And that's why, and that's the main purpose of Beanstalk. So what Beanstalk does, Beanstalk simply sets the entire environment which needs to be done, which needs to be set up before the application can be up and running. For example, here we need PHP, here we need also the Java environment to be set up. We also need Python to be also set up here, right? Then we need, then again, for setting up these different environments exactly as per the requirement, then this is all the job done by a simple service called as Elastic Beanstalk, right? Elastic Beanstalk here. So Beanstalk main job is to simply make sure the entire environment is exactly set up as per the code or as per the requirement of the application that we are trying to develop here. All right, that's the main purpose of having a Beanstalk. And then we have load balancer. Load balancer is simply, let's suppose we have a huge amount of traffic coming in, right? We have a huge amount of traffic coming in. Now, if we want to distribute the entire traffic to multiple services, multiple servers, like we have multiple EC2 instances deployed here, right? So instead of pushing the traffic or the entire traffic to just one instance, what we can do, we can simply push the traffic to multiple instances here. We can do that so that the entire load can be well distributed in different instances here. We can do that, right? And that's exactly what we achieve using Elastic Load Balancer. And that exactly we achieve using Elastic Load Balancer here, right? And same way for auto scaling. If we want to scale up the resources, that means we want to increase the number of servers, or if we want to increase the capacity of any servers being deployed, then that can be done using the auto scaling service offered by AWS. Right? So these are all this computation service offered by AWS here. All right. Now next is we have a storage service offered here. So in terms of storage services, here we have S3. S3 is called as Simple Storage Service. S3 is called as a Simple Storage Service. Again, kindly excuse me for this beautiful calligraphy, guys. Again, that's what happens when we try to do right using a mouse. So S3 is simply simple storage service offered as a object storage option offered under AWS. Now in S3, what we have is here we have multiple objects. Now when we say objects, we simply mean all the files, as in all the media components, for example, images, videos, PDFs, static websites files, right? So any kind of file and document that we need to store, we can simply upload those in S3. And again, then we have a bucket. Here we have the concept of bucket and objects. So bucket is, we can say, a container. Bucket itself is called a container itself, right? Just like in our own Windows, to understand this in simple layman terms here. just like we have our windows, right? So in Windows, we have multiple partitions, right? So for example, here we can create partition like C, D, E, F, G, H, I, J, K, L, M, N, M. Like we can create multiple partitions here, right? So we can say these are what? These are simply containers. These are what? These are containers here, right? And again, and then if we want to now, these are what? Containers like bucket. So we can say these are what? Let's erase this up. So we can say these are what? Simply containers. Like we have a bucket, right? And when we open up any of these buckets here, what we can do, we can start storing files inside these, right? Then we can start storing files inside these. Now, this can be a simple file, or we can create multiple folders inside it, and then we can store any kind of files inside it, right? And that's the same concept followed by S3 as well, as a part of bucket and as part of objects, as a part of storage service offered under AWS. All right, and then we have the content delivery network as a part of CD. And content delivery network is, suppose if we had our website deployed in some other regions, right? So basically, suppose say when we have our users sitting in North Virginia, right? I suppose here our users are sitting in North Virginia and we have deployed our EC2 servers in Mumbai, right? Then again, although the users coming in from this entire region here, they can also access from North Virginia, they can also access the same platform easily using Mumbai as well, right? But again, they will require a good amount of time in order to access the server or files that has been stored here, right? So just to reduce the amount of time here, just to reduce the latency, there we can now there AWS uses something as CDS, as CDN, content delivery network, so that the entire content can be delivered in a streamline, so that it becomes available at a higher speed, and the entire integrity of the data also remains intact. That means the data also does not get lost in between the transmission. That's the main idea of using a CDN for making things faster. And then we have elastic block storage. So now these are different storages as a part of volume, right? So just like in development, we can create multiple volumes here, and then we can attach those volumes with the instance that we have deployed in EC2 service, right? So if we have multiple, now suppose if a single instance, a single version can be attached to multiple volumes, we can do that, right? Now, just like now, again to understand this in simple layman terms here. Now, when we are setting up our PC, right? So in a PC, we have if we want, we can attach multiple hard disks as well, right? We can do that in a single PC, in a single server. What we can do, we can attach multiple hard disks as well. Like we can attach a simple SSD, we can attach two SSDs, and we can attach one HDD as well, right? We can do that. So these all are mounted to a single server that we have deployed here. This we can say is simply what? A simple EC2, right? But we cannot mount the same, suppose if we have a hard disk here, right? So we cannot mount this hard disk to some other instance as well. We cannot do that, right? But a single instance can have multiple volumes attached to it as well. All right, and that's the main concept of the volume as well. So volume is also again elastic block storage, called as EBS, is again a service that through which we can attach multiple volumes to the instance. Because a server, suppose if we had deployed any website here, right? So obviously website needs to store its entire files in these volumes attached to it only, right? And that's why that's why the main concept of EBS is, that's what it is. All right. And same way here we have Glacier. So Glacier is a service for archival of data. When we say archival of data, we simply mean we have some data that needs to be archived. For example, let's say currently we are working in 2019, right? Now, suppose let's say we want to fetch the records. We want to fetch the records for 2009, right? So obviously we don't store the records of 2009 at a desk, right? We won't find the files of 2009 here laying on a desk or even laying in a room itself, right? Because again, this is old data that we do not use regularly, that we do not need to use on a frequently basis, right? So what we can do, we can simply archive this data. That means here we can simply send it to, so we can say simply back service or back storage service, from where we can start fetching the data exactly as per the requirement, right? That means if we want to access this data here, it won't be readily available. That means first of all, here we have to generate a request, and then it can be made available to us in a given number of hours. That's the main concept of Glacier as an archival service offered by AWS. All right, that's the main concept of using a Glacier service here. And same way here we have Snowball. So Snowball is again used for physical transfer of data from to AWS infrastructure. So Snowball is a physical device. Snowball is now, unlike all the services which are completely based on cloud. So Snowball is a physical device offered by AWS, right? Now let me show you how exactly Snowball looks like. Okay, we don't want to see the Snowball here. So Snowball from AWS. All right. So now this is, as you can see, this is a physical device offered by AWS that we use for transferring of data or transferring of petabytes of data. Suppose let's say, and again, transferring petabytes of data, and again, that data which is highly confidential, or again, there's a bigger risk involved in transportation of these data. For example, suppose to understand a simple layman terms here, if we have a bank here, right? So now bank has multiple data that needs to be transferred to the cloud as well, right? But bank cannot rely, because for security reasons, obviously bank cannot rely on any open net connection, because again it will be highly unsecured, right? Because again here it contains information like we have the financial records, transaction and whatnot, right? So instead of using the internet connection here, or suppose any secured line here, what banks can do, they can simply use a service called Snowball, right? So they can transfer their petabytes of data into these physical devices called Snowball, right? So these are what? These are the physical device offered by AWS, and these are highly tampered free. That means once the data has been loaded here, even though these different Snowball gets into hand of suppose some unauthorized person, right? Still the data cannot be stolen from these. These are tampered proof, right? And that's why these are used in now. That's why this is one of the good use cases for Snowball. That is again a service offered by AWS, right? So AWS will itself deliver these for starting the data transfer, and once we are done with the entire data transfer, this will be taken back by AWS team itself. And at last, we have storage gateways. If we are transferring data from using the net connection, using the internet connection, again, we need a platform in between. For example, we have our own data center, right? And again, here we have cloud. So just to make sure that data is again delivered efficiently, plus the data integrity is maintained. That means data is not corrupted or lost in between, and the connection is also kept intact, right? That's why we can use something as storage gateway for these purposes. All right. So that's the entire overview for the storage services offered under AWS. So now let's do one thing. Instead of EC2, let's focus on deployment of S3 storage services here, right? So now suppose let's say we want to store any files here as a part of service offered by AWS, right? So here in the dashboard of AWS, here we can look for a service named as S3. So you can even look for the service here itself, or here we have a search bar through which we can search for all the services available on AWS, right? So here we can search for S3 here, and now let's click on it. Now the main motive of this hands-on here, guys, is to simply see how the storage services work here, right? And how we can start storing files on AWS Cloud Platform. Now, once we have opened up S3, this will contain the list of all the available buckets that we have currently created into our account here. So these all are dummy buckets that we have currently created, right? So in order to get started, if you want to create a dummy bucket, what we can do, we can simply click on create bucket. Let's click on create bucket here. So here we can give this bucket a bucket name. Suppose we want to give this name as Edureka November here, right? And then we can choose a region in which we want to deploy this bucket. So as we had discussed, AWS services are deployed in multiple regions out there, right? So for example, our users are based in, suppose in Singapore, right? Then definitely we don't want to launch this in Paris. We don't want to store this in Ireland. We don't want to store this in Mumbai. We don't want to store this in, suppose in Stockholm or in Sao Paulo, right? We want this entire bucket to be available in the closest region to our users, to our end users, right? So here we can choose, suppose if our users are based in Singapore, we can choose Singapore, and then we can click on next. Now we can keep all of these settings by default one by one, because again it contains access for versioning, for object level logging. These things will be discussing in detail once we start our entire discussion. So we can keep this as it is for now. Click on next. Again, we can, if we want this to be accessed by everyone here, if we want to share this file with everyone, we can simply remove, or we can simply unblock all the public access. We can do that. Click on next here. And now here we can review the entire setting that we have opted for this bucket. Once we are done, we can simply go ahead and click on create bucket. So as you can see, now this bucket has been created, right? So now if we open up this bucket here, we can simply start, now we can create folders, or we can start adding files to it directly. And now if we want to add files to here directly, we can click on upload. Here we can choose a file, so we can simply drag and drop the files as well. For example, let's say we have a static HTML page here. Let me show you sample static website, a static page here. Now, for example, here we have a static web page here, right? So now if we want to upload this file here, we can simply go ahead and we can simply, let's do one thing. Let's go back to desktop and let's simply upload a sample page here. Let's upload this. Now, as you can see, now we have this page uploaded here. Click on next. And here we can choose the right access here. Click which we should be focusing on as we continue ahead. And these are different classes as per the requirement here. That means now, just as an overview here, if we don't want to use this on a frequently basis, then we can use infrequent access. Glacier is when we don't want to use this file for long period of time here. We want to archive it. Then we can change the class to Glacier as well, right? And we'll be discussing these parts in detail once we start our entire discussion here, right? Now, once we are done, we can simply click on next and upload. And now this file will be uploaded here. As you can see, upload has been started. And now we have the file uploaded, which we can open it. And again, if you want to access this, we can simply make it public. And now what we have is here, we have the link here. We have the object URL link here. And if we open this link here, we will be able to see the same basic web page that we have currently created here, right? As you can see here. Thank you so much, guys, and have a great day ahead. Take care. Bye-bye.